Good morning, everybody. That's the most running I've done today. I don't know about the rest of you, but wasn't that party last night truly was out of this world. So, yeah. The organizing team has done a great job.
Yeah. And I know I was excited to finally get my picture taken with Darth Vader and a stormtrooper.
Yes.
Yeah, I sent it to my daughter, and she was like, awesome. Yeah.
If only we knew how to use Snapchat.
Exactly, yeah, exactly.
So this morning we have a wonderful way to start our day. Let's try to figure out how these things work.
Yep.
We're very pleased. Oh.
Yep. Yes. So during the talk, if you have questions, you can go to slido.fme.
But also, I think this is meant to, if you really want to think about putting Dawn and I on the hot seat, you can start putting some questions in there as well. Because what we got this morning is a special guest speaker, and then Dawn and I are going to take our place between the ferns, so to speak, and be peppered with questions.
Awesome.
And so we're just going to try to run out the clock, basically.
That's right.
That's going to be the strategy. So that's
all
right.
That good stuff. Yeah. So ask me about my hair, and I can go on about that.
Yes.
Yeah.
But
yes, we have a special guest speaker this morning.
Yes.
Who we know we've heard him speak before in a year ago or 2 years ago.
Dawn and I can't remember. When was FME Days?
Yeah.
Was that last year? Last year. Wow, it feels like a lifetime ago. But we've heard about the work that Jan has been doing through some of the SAFERs have gone there, and Ulf and others, and Contera, about the fantastic work that's going on at the European Environment Agency.
Yeah.
And so when we heard Jan speak, we really felt strongly we had to find a way to have him address the broader FME community worldwide.
Yeah.
And so we're so pleased that Jan's able to join us this morning.
Yeah.
So Jan manages a team of 10 people collecting data for the European Environment Agency. He's worked in data management for more than 20 years, previously developing in Python, Flex, and several Microsoft languages. He has the rare combination of having great managerial skills, great people skills, and frankly, genius technical skills. And if any of you have looked on FME Hub, you will know why we can say that with confidence. Yeah. He's done amazing things there too. Yeah. Working at the European Environment Agency using scripts to gather environmental data from many countries in different formats, Jan quickly saw all the stuff FME could be automating.
Yeah, so he he brought FME into the EEA in 2013. So not that long ago, really. No. And the thing with Jan is he realized early on about the value of modularization. And so he was able to use modules to build many things at FME, and then he could just pull them together, reuse them. As Dale said, Jan was one of the earliest to really embrace FME Hub, and he's pushed a lot of good stuff there. I know the Azure, there was several Azure transformers pushed up there even before we knew or worked much with Azure, so we're very excited about that. And there's also a Microsoft Word reporter he did, and we'll hear more about Microsoft Word a little bit later. Yeah. And he's wonderful to work with. I know every time we get a chance, you can talk with Jan, and the conversation is just fantastic. And the challenges and the data the things that Jan's doing with data is just great. So so please welcome Jan
Bliki.
Good morning, everybody. Thank you so much that I can speak here and present the European Environment Agency and what we're actually doing. FME is an amazing product and has changed really our life, and I'll try to present that a little bit in my presentation here. To give you an idea, this doesn't work. Oh, yes, it does. EA is located in Copenhagen, this little dot over there. I'm myself coming from Belgium, which is even harder to visualize here on this map because it's so small. And I'm actually living with my family in Malmö, in Sweden. So I'm actually covering 3 countries already. I feel as a real European, I would say, and I'm proud about it. And one of the biggest things I think about Europe is basically the diversity of cultures that we are dealing with. I think we are one of the biggest continents that has such a culture difference. And there are a lot of Europeans here, right? Can you put your hands up? Because I have a feeling that We are loaded with Europeans here. It's quite amazing. So yeah, what we are doing as European Environment Agency is we cover about 33 countries today that collect data and deliver this towards us as a central body in Copenhagen. We have different agreements, so it's not only the EU members, but also collaborating countries. You can see quite a lot, even Algeria, Libya, and Egypt are somehow working with us, and all of them are delivering data towards us. In order to do that with an agency that's 180 people more or less in Copenhagen, so we're not really big, we need to have people on site. And we do that by hiring topic centers, we call them. So we have topics like water, biodiversity, air, land, on noise, climate. For each of those topics, we have hired 10, 12 organizations that are working with us, institutions, even universities, and they stay local in these countries to help us bringing about 1,000 organizations together that deliver, collect environmental data and stream it up towards us so that we can make European data sets out of it. So this is one of our major tasks of my team. My team is dealing with generating these European data sets so that they become comparable, so we can actually say something on a European scale to all those countries. And hopefully these data sets are then also reusable by them, so they can see how they are against their neighbor countries, or their policies working, and so on. And like I said, we are dealing with quite some thematic areas. This year, we more or less have about 80 data flows we are managing, and this is constantly growing, mainly because of our success of handling them. So 80 plus data sets on water. Just think about all the river networks, the stations on river networks. Think about air quality, many, many stations all over Europe that are delivered towards us. Think about protected sites that we are collecting and we are knowing which species are in there, and so on and so on. All those data sets are available publicly as open data sets that you can find on our website at the EA Europa EU. So if you're interested in them, go there and you can download them for free. But we're also using those data sets, of course, ourselves, and we are using them in two major ways. One is about making interactive products. Think about map viewers or think about dashboards that are allowing you to play with this data, understand, and allow you to data mine it. This meant for the global public, let's say, but also for our experts in the Parliament or the European Commission, those that are making decisions about what kind of policies we should make in order to improve the environment. They, of course, are one of our biggest targets, I would say. So many of these products are on our EA website, but we're also building this kind of super sites that are meant for the expert and allowing the experts to play with this data. Biggest issue that we have is to make these data sets as qualitative as possible. The better we can make them with less exceptions in it, the easier they're going to be used, right? And I think all of you have this issue as well. And this is one of the biggest challenges we have. This is a very generic representation of how such data flows are processed, but they're all following that same concept, I would say. You have always this extract situation. You're extracting a data set from an environment, from the different countries. And we have a system just before that. It's a little website. We call it a ReportNet. It's a website with a built-in file system, let's say, and some simple XQuery, QC technology that allows countries to publish their packages on a yearly basis, on a monthly basis, or every 6 years. It depends on what kind of data sets you're dealing with. And we grab those data from there using FME today. And then we have those three major blocks. We are doing some QC on that. We're doing some cleaning on that. And we are conforming it together with all the data sets that we built before. This is about 70% of our workload. the complexity of handling data in that way. Even if we have very detailed specs about how data should be delivered, we all know that, well, not all of them gets fixed. And we cannot just block everything, because then we would never get data. So we have to find those elements that are really important to tell countries, you have to fix this, otherwise this data is not qualitative enough. But there are a lot of things that you can grab and say, okay, we will deal with it. We will tell you that this is not so good, and we would prefer you to fix it, but we have ways of cleaning that up, yeah? And then we have this delivery part, which could be all kinds of things, yeah? Just to give you an example on the formats we're dealing with, the majority of the data is XML, yeah? Yes, well, it is also a pain, I would say, because it is a standard, but it's such an open standard in the sense that you can do anything with it. Every single data flow has its own standard, you know? And since we are the European Union doing data sets, then it becomes the European standard for that data flow, which is kind of crazy. But that means that for every data flow, we have to compile the information in a way that we can collect it. But there are also other formats that we deal with. For example, Excel is a very common one. Access databases is a common one. Shapefiles, of course, because still every tool that is out there, whether it's open source or industrial products, you can basically write out shapefiles. So it's still a very used common format. But in Europe, because we are using Inspire more and more, you also see a lot of GML, for example, as formats. And there are very many different versions there, which makes it quite complex. Again, FME being a very good tool to solve all those issues. What we like on FME is that it has this underlayer and integration of all these other products that we are working with. We are strong users of SQL Server. Most of our data that we are bringing together on a European level is first stored in an SQL database. So we are using the spatial and the tabular component a lot there. But as well, we are using ArcGIS a lot. You have to think that we are actually building a quite big data infrastructure, an enterprise of systems that needs to go work together very well. And FME is almost, the pipes of the system, I would say, like we saw yesterday. This is definitely what it does for us. There's quite some open source out there, and many people are using that. If you're not having the enterprise concept like we are having, then maybe simpler software can do the job as well. So why buying a huge package? But for us, we need to then be able to deal with these formats as well. And we are Microsoft Azure users a lot. We are going into the cloud. It's one of these environments that the European Commission has already adopted, and it helps us a lot to scale up things, and I will show that a little bit later. In the past, I would say 4 or 5 years ago, we were using Python a lot to do all this work. And it works great, but it is quite a maintenance. All of you who have tried that, you will realize that 10% of the code is actually doing the work, 90% is making sure it's logging, it's checking whether the data is right and convert it even before you're actually launching your process so it doesn't crash, right? This costs a lot of maintenance. And as I showed before, we are working with a lot of organizations. Every 4 years they are changing. That means that you can have quite some people moving around. And if they are writing code and creating things, and then the next one picks it up, and it is not really following conformal processes, you end up with quite a mess that is redone and redone and redone. And that's why we said we need something that is better. We need something that goes on a higher level, which is not only focusing on developers, because developers hate maintenance. I can understand that. We all love to create. I'm a developer myself. So we like to create, but maintenance is not really our thing. So if others can help us with that, it would be definitely worthwhile. So what we needed is something that data managers as well can find their way in. And that's what FME really allows us to do. The other is our GIS users, or operators. They also would like to play a role there. And the fact that they can take the things in their own hands helps also to make these processes easier and faster. Let's go a little bit in detail about what it is, what we mean with QC, and why we're splitting this up. When we do quality assurance, we never do the cleanup directly. We are never executing and say, change immediately from UTF-8 or from a local encoding to UTF-8. We like to first figure it out, did that happen? So we can build reports around it, we can set flags, so we can tell our administrators that are managing the data why is the data the way this is at the end of the process. So QC is always important in your whole process in order to do that. It also gives you the advantage to write reports out of it, which we do a lot. We make very nice Word reports, which we then give back to the countries that are delivering data towards us. And why we do Word and not PDF? Well, our thematic experts, they most of the time review those reports and simplify them or make them more readable, because the easier you do that, the more chance you have that countries actually look at it. If it's a very detailed, big file of 300 pages, most of the time it just falls in the bin. They don't have an interest in that. But what is this QCs? Well, mainly syntax format, for example. Is it the right XML format they're actually delivering? Character encoding, did they use their local encoding or did they use UTF-8? Do they follow the code lists we have given? Notice that most of our countries speak a different language, so you can have all these effects that they have given the data in their own language and we cannot map it. Things like that can happen. The no-value interpretation, it's happening quite often that different systems have different means of how to define what is a null value. You need to figure it out. Even if you tell in your specs you should use the null value, for example, as a way of saying it is no value, this happens quite often that they forget that, and that we need to find ways to filter that out. We also, in many cases, look of what they have delivered before. This to figure out, did they create gaps or they're missing pieces, so or they're outliers that are strange compared to the data we had before, and things like that. Then identifiers, it's a big issue. In many cases, data is reported to us again and again. We want over years to have this data compatible. You always need identifiers that stay fixed, so that an identifier towards a river basin district, for example, or towards a lake, it's important that it gets the same number so we can start using these things again. So in many cases, we have methodologies and mechanisms to figure out, did they change their identifiers? Because that happens if they do an upgrade of their database or whatever. These things can happen, so we can report that quickly. Spatial accuracy, overlap, reprojection, these are all common things, right? FME does a lot of those things already. There are so many built-in transformers that do that. But to make life easy and also to make us all do the things in the same way, we start more and more building our own specific transformers in order to assure that. As I said before, we have, I think, something like 50 people working with us together. To make them all work together and do the same thing, you need to have a kind of framework in order to do that. So this is one of our solutions in order to do that. What I forgot to mention is that 2 years ago, because we are all over Europe and working together, we needed something far more than just having databases locally and send database files to each other. What we did for the people that work directly with EA, or consultants, all these topic centers, and ourselves, we built a cloud-based data center where everybody with remote desktop can go into, and the software is there available. So we have FME there, we have ArcGIS there, we have a number of open source products there, we have SQL Server there, and we are all working within one central place, although one person can be in Spain, the other one in France and in Greece and so on. So we are bringing that all together, right? Cleaning data. Cleaning data means that if once we figured out that there are issues, can we not fix that during the process, right? Again, lots of components there that allow us to do this, but we're also building our own specific ones. let's go through quickly. Fixed spatial data, meaning, well, they use their own local projection. We can reproject that if the details are given towards doing that. Character encoding, we can solve that. The no value, they used the 9,999. We can make nulls out of that. Language-specific ones. Access is one of the most horrible tools for this kind of problem. They have their own language built in. If you export that to XML, suddenly all your booleans will become translated in your local language. So we made a component that solves that for us. Many do their editing these days on HTML pages, on websites. So body text and descriptions, if you want to really reuse that and make that coherent with all other data sets, well, we like to strip those out. So we made some intelligent tools to strip those things out. Date time, and I'm super happy that 2017 has actually built this in now, because this is one of the major issues we are dealing with. Time differences on the European level, I think most of you others must also have similar cases like that, but date and time issues are a big problem for us. And this has solved, these functions that are there now have solved a lot of issues there. And then we have all those GML versions. There are several out there, but you also, many people build XML with GML inside. There is GML with XML inside. God knows what. There is all this combination. It's one of the things that I hate or dislike on XML and JSON. They're too open. Yeah, you can easily go and edit them. Yeah? If it's a binary file, you can't do that. So in that sense, it is a disadvantage. But yeah, it also gives a lot of flexibility, of course. So it's a pain we have to live with. Statistics, let me give you a little bit of an idea of what kind of data we are actually dealing with on a daily basis. And it's very diverse. I mean, we have cases, take the air quality as a starter. 1 billion records of data is coming in our infrastructure that we need to store. In many cases, countries deliver that on several occasions again because they give us the raw data in the first hour. 3 hours later, they start cleaning up. They realize that certain stations are behaving bad. They send this data again. So altogether, let's say about 5 billion records have been processed through FME before we're actually having our final data set out. And we have that on an hourly basis. Yeah? The complexity here is, what if the system fails one day? For example, our internet connection dies through the weekend. Then suddenly we have a backlog of millions and millions of records that needs to be further processed. How do you do that, that you can handle the backlog that is there when data keeps coming in on an hourly basis? So if you, for example, need to process 100,000 records per hour, you definitely need to do it much faster than in an hour in order to be able to deal with backlogs like that. And this is the kind of elements that we are fighting with a lot when we're dealing with this kind of amount of data from an FME perspective. We need to figure out how fast we need to test that. We need to use multiprocessing, several machines, several engines at the same time. We're using several databases behind the scenes so we can deal with this fast processing power. Other issues like we have is on spatial data. You would be surprised, but not EA doesn't always has the control over what is agreed with countries and how data should be delivered. This takes, for example, that the specs might not talk about certain important elements. Spatial format, just as an example. So suddenly you get data in shape, in GML, in JSON spatial data. Somebody got a GML extract from a WFS, and you get all kinds of stuff. How to deal with that, you know? And we can't reverse that because those agreements are made on a political level. They are set there, and the data comes and starts streaming in. So in many cases, we have several cycles of processes. What we in these cases do is we are inviting all those data providers and try to get common sense about what is the best way to continue on that and build these extra specs. But in many cases, we have to process the first cycles like this. And again, there are a lot of elements on that. We have a lot of spatial data that needs to be quality checked over different levels. Think about the Water Framework Directive, for example. You have a river network that needs to be compatible with the River Basin District, needs to be compatible with all the boundaries over the countries. Yeah, the lakes need to link with rivers and so on. All this kind of checks, when data is being published towards us, we are basically building workspaces that FME then processes and reports back immediately. What FME really made us a difference is that in the past, this was all done by our topic centers. The data team in EA was not really very deeply involved, and I'm talking now 10 years back. What is happening is that most of them, because there's such a changeover of these people, we are seeing that they're doing much of the things on a manual basis. So the data delivery, when it came in to EA, to actually getting a European data set out, was taking more or less a year before we had those results. And in a year, a lot of things can happen. Many countries are using consultants to do that kind of work. So when they delivered, and a year later we say, hey, there is a problem, those people are gone, right? So it's very important for us to be able to provide immediately results back towards them and process as much as we can the data so they can instantly see the day after if their data actually fits with the rest of the European Commission data with all the other countries. Frequency is another issue. We have data coming in on a continuous basis. There you have the issue of machine to machine. They did an update on the other side. It doesn't work anymore. We need to get in contact with them immediately to actually solve these issues. The other is about data sets that take 6 years. So every 6 years they deliver. And in 6 years, a lot of technology changes. It only not changes on our side, but also on the country side. So you get a lot of other kind of frictions and problems to solve a year before they're actually starting delivering. So these are all the kind of ideas that we are facing. On the right side, I show you a little dashboard. And this is basically a dashboard showing our FME server that we are having. We have about 20 desktop licenses today and about 16 engines running on one server. And we have another one which has 8 engines for the let's say, processes that take more than 5-6 hours to process. On this machine with 16 engines, it does all kinds of things. And I will show you a little bit later. But just to give you an idea, by average, we have about 11,000 jobs that are run every day. Yeah. And we schedule the processes so that some of them are being pushed down. So for streaming, data is going much directly through, where things that are meant as batch, they are pushed behind. So when the engines are getting available, they are actually running in the night. So we're trying to average out over the time. So the one part of the presentation shows every hour of the day. So what we're using this kind of dashboards for is to understand where do we have freedom, or in which hour could we put more jobs, for example. So we are using this kind of technique in order to balance out our server as much as we can. We are using the entire framework of FME, and we do that in order to deal with all those people that are out there to kind of find ways to make them do the same thing. We also have training courses, of course, since we have quite always some new people that, for example, don't know FME. EA is always organizing trainings in order to bring those people in, and we show them then how you handle the data flow and how you manage the data flow. There are 2 reasons why we need this shared FME folder. I don't know if any of you are using that in combination with other, but it's a brilliant way of communicating new transformers to the rest of the team or templates. And we are really strong users of that. One is to deal with the complexity. How do you make efficiency a developer and a guy who can really make amazing things pass on information that a database expert immediately can use? So these are the kind of things we're trying to do. How we can make complex things easy? Well, we put it in a transformer for them. The other is about integrating, do the same things in the same way. So if you have an infrastructure that is your own, you don't want to have everybody doing it slightly different, because if that system changes, you need to go in each of those workspaces to kind of fix it. By putting it in a transformer, you can kind of centralize it. And this is the way of how you can solve that. FME server is really our workhorse. I mean, it really helps us going home and relax about things because the server is dealing with it. We're scheduling a lot of things as jobs, but we are big believers of the data streaming. If you want to have an enterprise where all systems work together, data streaming is a beautiful way. You can build your own REST APIs. You can mimic REST APIs of systems that are out there and get things move around. Data download, yeah, we all know what that means. We have a lot of clients who are grabbing, for example, the air quality data from our infrastructure on a daily basis. They can specify exactly which parameters they want, from which day, from which hour, and then FME provides them this data in either shape or CSV, and they integrate that as well. So there are scripts on the other side, in some cases also FME servers on the other side that talk to ours to do that kind of work. And we use a lot of notification and the log mechanisms within FME server. We have even scanners that are going through the logs to figure out are there any particular new issues or errors that are coming out. A system like FME server is always dependent on many other infrastructures out there. Just imagine that one of your databases is bad behaving. This will have an impact on all your jobs that are on the FME server. Yeah? So this logs and this notification helps us actually to bring those things out and either stop a schedule, which we do sometimes automatically. If we see there are too many in the queue, let's pause the schedule because there is an issue, and give a notification towards the administrator that he should check his database. So this is the kind of examples we are dealing here with. Let's talk about something totally different right now. What I showed you now is about how we handle data. But we have also big jobs in about how can we make this data easily accessible to our experts out there. And since we are dealing with a lot of thematic areas, think about nature and land and air, for example, how do you make those groups work together? How do they make their data available to others? And many of those experts are also not GIS experts. So we have a lot of statisticians. They like to know how things are related to each other. And let me give you an example. Imagine you have a protected site. How does a protected site, how is the constellation of a protected site compared to the land that is in there? So how much is water? How much is forest? How much is concrete, as example? So if you have to cross this kind of different worlds, we needed an environment that allows us to do so. So what we did actually is we made a very small web application that hooks up to a database, and it's just keeping metadata. So any thematic group who has a data set can publish their data set in there. And they can keep even all their versions in there. So it's a little mechanism where we can upload their databases and their spatial data. Once they have done that, we can process all this and make it available in a Tableau. And I will explain how that works. So what we did is we built a giant grid over our entire Europe, and each grid cell got a number. And we do that for 100 by 100 meter resolution. Yeah. So if we push in, for example, a data set like land cover, it would come out as records, about 200 million records for that data set. We do that with all our 80 data sets, plus another 100 data sets we'd get from another. Yeah? So you get a couple of billion records that we are dealing with. But if you have this kind of simplified environment, then every number in the cell makes a relationship to all the other data sets. So and if you can, in that cell, mimic all the attributes that you have on it, you can start building very beautiful environments that you can use in Tableau. The processing of this is the issue, right? So what we did in FME is we are using point cloud as a first step. So when data comes in towards us, we simply overlay it with a point cloud, which is very fast in FME, and you can get this 200 million records all being assigned to all the attributes that are in your data set. And we export those, zipped, Yeah. We zip it also because the major cost of producing this is actually the writing to disk. You would be surprised, but that is what is the major cost. And once we have those zip files, we upload them in the cloud, in Azure, and we have a beautiful new database in there, which is called the SQL Data Warehouse. What is that? This is actually a federated database where you can basically on the fly ask for 1,000 machines to do your processing. So we are just uploaded all our data in there in a blob. When this database is off, you don't pay for it. You only pay for your storage. The moment we are going to combine these dimensions together, which we made another part in the website that our experts can deal with, they can say, I want to combine 4 versions of land cover with biodiversity and some air parameters. So what we do is we bring all those parameters together in a flat file for every cell. Then we execute the data warehouse. We open that data warehouse and say we need 1,000 machines. We ask it to aggregate the whole thing together. So we say how many times the cell is unique to all those attributes. And then you end up with about 200,000 records. Once the job is done, and you would be surprised, it takes about 20 minutes maximum. And we export it. We can bring that back to our local database. We shut down this database, so we paid maybe $5 for that. It's quite impressive. And we have a new data set that can be easily brought into Tableau. And this allows them to ask questions that we had never were able to do actually before in a fast way. They could do this by initiating projects that were doing this kind of work, but now we can actually industrialize this, let's say, and in that Tableau, they can start looking at this data on the fly. So this is one of the examples of how we are handling data and what we are getting out of it. And these dashboards, there can be many of them, of course, that are focusing on specific questions on this data. The way we also built this was completely in FME. So the only thing we did in a website was to maintain the metadata, and all the other processes are done by an FME server and run almost automatically by itself, and with some little flags in the database, what jobs it had done when, and how starts up the database in Azure, uploading of data in Azure, and all these things have happened. We built a lot of transformers, and we also try to make them available. Funny example here is we made a full integration with Microsoft Office 365. You think, why? That's crazy, no? But Office is the tool that many of our administrators or managers or staff are using. So if you could put things, for example, in their calendar of jobs that have run, processes, when did the country deliver something, and you make a special calendar inside your Outlook that you can control on it, you give a much better environment than sending emails, for example. So that was one of them. But we can also send tasks. We can also send read emails and write emails. And so we fully integrated it. There is a whole REST API doing that. It was quite easy to actually make that possible. And this is used quite often in EA. Another one, which you probably know, was the Microsoft Word. It was just mentioned. We use that a lot to build reports towards our partners in the countries. Again, it's a set of transformers that allows you to put pictures, raster data, tables, and text notifications, and so on, and then generate a report out of that. And Blob, Azure Blob. This was not yet existing inside FME. We had a big need for it. So I didn't build those myself. This was done by Sweco, Peter Segerstedt. He's a real guru, I would say. And he built this kind of tools for us in order to make that possible. So before I end my presentation, like Don and Dale have told you, I'm a big lover of the hub. I think this is something all of you should at least put one transformer in. You can use those transformers not only to quickly solve your own problem if somebody else has done it, but it's a very beautiful way of learning how you do things. Most of them are free and open to look into, and I learned a lot from that. It takes a bit of time. but actually the time that you spend to put things up gives a lot of learning or let's say educational material, and in some cases direct results that can be used. So I really recommend you guys to also look into that, and I will commit myself to put good transformers in there that can be reused by you guys. I'll leave it with here. If there are any questions, please. I'm ready.
Thanks so much, Jan. You know, yesterday Commander Hadfield talked to us about managing complexity and change, and what we've seen this morning is that you've been doing this for years, and particularly the last number of years. 8,000 workspaces, numbers of countries, incredible complexity.
Yeah, thank you. Billions of records. I also noticed that on your slide of formats, XML was number 1, number 3, and number 4. I just thought I'd point that out. And,
vote early and vote often.
Yeah, that's right. Vote early and vote often. Exactly.
Yes. So at our conferences, we tend to, or we have, it's been our practice to award a Pioneer Award for someone who has done amazing work, revolutionizing their organization by introducing FME. And so we're so honored today to be able to present this to you, Jan, for the fantastic work you've done.
Awesome. I'm sure my team will love this.
Yes. We'll get a picture over here.
We'll go on each side of you, I think. Yeah. Okay, the photographers. Okay,
awesome.
thank you.
Thank you
so
very
much,
much.
Jan.
Yeah, thank you.
Yes.
Bye.
Take that.